Well, hi everyone, and welcome back to the next session. Now, I'm often asked, look Westland, you're doing all this ZKP and blockchain stuff. What are the actual applications for it? And people ask that because they may be thinking there aren't any, but they'd be wrong. And so I thought I'd give a long answer to that question, or rather I wouldn't. I'd get my colleagues, Dr. Swati Rawal and Fabio Mereu, to talk about an application that they've been working on. And this is a technical expose of that application. So I hope you'll find that interesting. They're going to talk for about half an hour, and I'll pass you over to Swati and Fabio.
Thank you, Duncan. As we all know, during this summit, Paul launched our new product, EY OpsChain Contract Manager, and we also had a privilege to see it through a demo yesterday from Akshat. And this technical talk today that me and Fabio is going to lead, we're going to talk about the journey of this EY product, OpsChain OCM, which starts from an ordinary smart contract and into a product which is privacy preserving software as a service solution. So, these are the wrong slides.
So there's just a little bit here to read out about CPE eligibility, which I'll do.
Okay.
So this is, you should be bored with this by now, audience, but we'll launch 3 polls per CPE credit. Participants must attend fully each session, and participants must answer at least 3 polls per CPE credit to receive full credit. So you have been warned.
Okay, so this was all about the CPE credits that you will get for this talk. So moving on to the discussion. So how we start from how we turn the ordinary smart contracts into a privacy preserving SaaS solutions. So this is just a disclaimer slide that this is just a technical talk for your educational purposes and not to be relied upon for any professional advice from us. So apart from other features that this product has, one of the main concern for this product was to achieve privacy that it's achieved from Starlight. So the first agenda of this technical talk is to present Starlight, and then I will I will ask Fabio to take on this technical talk and talk you through the improvement that they made or scale the applications to a software as a service solution. Duncan has already introduced us, so I'll skip over the slides and move on to the introduction of Starlight. So Starlight at its core is a compiler, or you can say a transpiler, which empower its user to achieve privacy for the business use cases, and by employing their expertise in their domain and get a zero knowledge application for their specific business use case without worrying about any complex mathematics behind those zero knowledge applications. As a user of Starlight, one has to start with an ordinary smart contract, which lays the rules of their business logic behind that ordinary smart contract, and mark the things that you want private as secret, and move on to an intermediary step to a decorated smart contract which Starlight understands, and then just running a simple command Zapify, you can get an EVM compatible zero knowledge application from Starlight, which our team OCM uses for different use cases to give us a SaaS solution. So the intermediary step from an ordinary smart contract to a decorated smart contract uses some decorator that Starlight understands. So the first one is secret, which we all know. If you want any variable or any state variable to be private, you mark that variable as secret along with the function parameter or any local declaration interacting with that state variable, and thus making your things private and unknown to the public. The next thing is shared secret. This is quite recently introduced in Starlight. You might have a situation where you want to share your state with some other party or with some other party, then you can mark that state shared secret that will remain secret from any other party who doesn't know the shared secret, but it will be shared with the other party who is your sharer. So this can be very useful in case of when you have to do something like swaps. Then you can share your state with the other party with whom you are interacting and doing the swap. And with a very nice API that Starlight has, you can generate the keys independently for your commitments, and the both party doesn't have to interact with each other to generate those keys. So these are the two main decorators to determine which states you want private in your smart contract, and if you have any shared secrets which you want to you mark those state as shared. The next two decorators, known and unknown, are quite interesting as well as quite important for Starlight to understand how to store its commitment, whether in a partition manner or in a whole manner. So say if you have a scenario where where the state variable in your contract is say tracking your balances, and you want any third party or anyone else to increment your state, then you can mark that state variable as unknown. Then Starlight will allow anyone to increment your state without asking for the knowledge of the secret key. So you will end up having a number of commitments. We say that partition commitments for that state variable, and the sum of that variable will be represented, and the value of that variable will be represented by the sum of those parts. On the other hand, the known, if we have a variable marked as known, that means Starlight will always ask you to prove the knowledge of the secret key related to the commitment of those state variable. And whenever you are incrementing your state, it will nullify the previous commitment, or you can say replace the previous commitment with the new commitment. So you will end up having a single commitment representing your state every time, and the value of that state will be the value of that pre-image. So these were the four main decorators that Starlight has, and which allows you to move to that intermediary step of decorated smart contract. Now the next step was to run the Zapify command and get the application from Starlight. So this allows me to take you through the architecture that the Zap has that you got from Starlight. There are three main components that the Zap architecture has. First is the zero knowledge circuit. In your smart contract, all the logic involving the secret states will be carried on to these circuits, and they will generate the proof for the computation involving those states. The next component is the shield contract, which sits on chain, and any public logic from the original smart contract will be executed on chain inside that shield contract. As well as this shield contract verifies the proof that got generated from the circuit, and it stores the Merkle root of the commitments that were generated during the proof generation. But there is a third component, orchestration, which is kind of a bridge between the zero knowledge circuits and the shield contract as well as the user, as it contains all the API routes and services. So it commands the circuits to generate the proof if we call any function which have any secret states, and take that proof from the zero knowledge circuits and pass it on to the shield contract to verify. And after the verification, it updates our local database for the new commitments. So orchestration becomes an important part of the zero knowledge application that we get from Starlight, and the OCM has scaled up these orchestrations so that they can be used for different zaps, for different use cases, for the different smart contracts that we have. Next, to understand our product OpsChain contract OCM, we need to go through the services that the ZAP has and how these services completes our whole zero knowledge application. The first service that we have is a deployer. We have a shield contract that needs to be deployed on chain, so we need a deployer which deploys our shield contract along with the verification input which it needs to verify the proof, and it stores the deployment data that can be later used by the user of that application. The next service that we have are the API service. For each function in the original smart contract, we have an API service which the users can call to interact with the smart contract. As we know, an API service also calls the Socrates to generate proof for the computation if the function involves any secret. The next, after the verification from the shield contract, it updates the commitment database. The next service, as we have zero knowledge circuits, we have Socrates worker, which is a containerized Socrates for these circuits. Last but not the least, and one of the most important service that we have is a Timber. So Timber gets initiated as soon as we deploy the smart contract, and API service initiate the Timber, and Timber listens to this shield contract which sits on chain. It listens to the events, the new events that has commitments in them, and updates the Merkle tree database. So Timber is an important service, as when we have a number of contracts, Timber has to listen to them and filter according to which contract it's listening and update the specific Merkle tree for our product for our product OCM, which uses a number of different contracts. So all these 4 services makes our ZAP complete. Next, without taking much time for you, because I know all of you wants to know about our new product that we launched, OpsChain Contract Manager, I will ask Fabio to introduce you to this solution. Over to you, Fabio.
Thank you, Swati. So let me start by saying that what we've just seen is really exciting from a software architect's point of view, for 2 reasons. First of all, because it gives you the power of zero knowledge proofs without really having to worry about the little technical details that are in them, which can be very complicated. And second, because basically it gives us the opportunity to do business logic, any kind of business logic ideally, on public blockchain with privacy. So this is very powerful. How do we harness this power to make a real software as a service product ready for production? This was the challenge that my team was tasked with. So the product we're talking about, we already know it's called OpsChain Contract Manager, or OCM for short. And what this product wants to do is to allow the businesses to make digital smart versions of their traditional contracts, the contracts that you sign by pen, just to understand, by coding the business rules into the smart contracts and configuring the key contract terms and conditions into the contract itself. And then, thanks to that contract, businesses are going to be able to enforce the contract terms in their business transactions automatically across all contracting parties involved. So how does this work? A user chooses a template based on the use case that he wants to do in this product. There are going to be a lot of different templates for different industries, be it procurement or energy, as we saw yesterday, or insurance, and so on. Based on this template, you create a contract. You select the contracting parties that you want to involve in this contract, configure and put it up for review. Everyone reviews and maybe amends and then approves this contract, and the contract gets automatically deployed to the blockchain. Once it's deployed, the contract is ready for its execution phase. So that is, it's ready to check the transactions. Transactions from the different parties are filtered, are vetted by OCM to see if they are actually compliant with the contract terms. And of course, they can be all sorts of transactions. They can be, for example, for procurement, they can be purchase orders and invoices, or they can be insurance claims, or maybe energy bill calculations, or all kinds of reconciliations, so every kind of transaction. And OCM, based on the smart contract with the rules in it, can approve and certify it with a blockchain transaction so that everyone knows that that transaction is for sure correct. Now, here the need for privacy is pretty self-evident, right? Because we are on public blockchain, we are dealing with private contracts, so with contract terms, with details about businesses. We are also dealing with details about transactions, so volumes, prices, and so on. We don't want our competitors to see it. We don't even want the general public to see all of it, right? So that's why this product is only possible thanks to the zero-knowledge application. But what do we need to do to make this happen? Okay, so first of all, we want to do a software as a service, so something that clients can subscribe to. And we want to do it with self-provisioning so that there's no development involvement, no other intermediaries. Users are just going to go there, create their contracts. They are going to have them deployed and usable automatically, and nothing else is needed. Then, of course, we need multiple contract types, at least one for each one of the templates that we talked about, right? Because we want to cover as many use cases as possible. And we also want to be able to expand this collection of use cases in the future. Then, of course, we need authentication and signing. We want, first of all, to restrict the access to the platform to subscribers trivially. And now we also need to know who's allowed to do that, so whose data belongs to, and we want to use the right wallets for the transactions and all of that. In a production environment, of course, it's really important to have horizontal scaling, both for performance reasons and also for availability reasons, because, of course, every modern architecture absolutely needs this. And we also want advanced transaction management to make sure that our transactions are dealt with in a robust and fast and efficient way. Okay, so what were the challenges that we had with these different requirements? So first of all, for self-provisioning, the Starlight app is made to be self-contained, right? It's quick to be set up locally. It's easy to run. It has a nicely defined environment, and it's designed to have dedicated resources for this purpose. So this doesn't really translate immediately to what we need, right? Because if we want to dedicate resources to every single contract instance, then we need to deploy them every time that